All right, so what I'm going to do right now is let you in on a secret, my way of graphing a parabola. And what it does for you is it allows you to draw the most beautiful parabolas ever. You know, I just heard from someone in class that said that, once you start connecting the dots, it looks bad. It doesn't look right. A parabola shouldn't be pointy. A parabola should be symmetrical, and it actually, something about a parabolic curve is the importance of that curve. I talked to you guys about speakers and satellite dishes, flashlights, how the curve of a parabolic dish allows for, say, a flashlight, the light bulb of a flashlight, the light that's coming out of that bulb, everything that hits that dish will bounce off of that curve on the inside at such a way that it creates this beam of light coming out of it. So this curve of a parabola is so important. So let's chat for a moment. So I'm going to move my graph paper. Also, I highly recommend, these are actually Post-it notes of graph paper. So when we start graphing a lot, they come in handy. So like you just kind of peel this guy off, boop, and stick it in your notebook, no matter what kind of notebook you have. So these are kind of nice. But when you were younger, elementary school say, you sometimes had a teacher give you a sequence of numbers, and they would ask you guys, like, what's the pattern? What would the next number be? And when you're young and in elementary school, you don't really know a lot of number processes, right? Like, adding and subtracting really well. Then maybe at a certain part, you start to know multiplication and division really well. But I had even tutored a sixth grader. I think he was in sixth grade. Cutest kid ever, actually. Like these thick glasses and these chubby cheeks. And he said, every other word. He used to push his glasses up like he was like a cartoon character. He was so cute. He was like, and he just pushed them up on his face, little nugget. But I was going over something with him and I said, oh, they're perfect squares. I think his brain exploded. He's like, what? Because when I said the word square, he's picturing the shape, a square. And I'm telling him 9 is a perfect square. He's like, what? He didn't know squares yet. He didn't know square roots yet. He was in sixth grade. I've been teaching high school. I don't remember when I learned what a square was or a square root. So little kids don't know that. So keep that in mind. Now, if I was the teacher and I gave a bunch of elementary versions of you, picture elementary you, a pattern, and I was like, what's the next number? Or describe the pattern. So I'm going to write out a pattern. So think about what like second grade, third grade version of you would say for a pattern. And remember, your strengths as a second grader are really addition and subtraction. Like that's where you're at. So think back, way back, second grade. You're in second grade with your second grade teacher. And your teacher asks you to figure out, you get a sticker if you figure it out. What is the pattern? What would the next number be? What would a second grader say? Remember, your strengths are adding and subtraction. Addition and subtraction. What would second grade you say the pattern is? How do you get from one number to the next number? Anybody want to think out loud? Anybody want to share an idea? Go ahead, Hashara. What would second grade Hashara say?
Second grade me probably wouldn't know what to do, but
what about third, fourth, or fifth grade?
It goes up by like odd numbers, so like
beautiful.
+1, 3, that's 5.
Exactly. Oh my God. Usually it takes us a little bit longer for somebody to spit that out, but you got it right on the money. First try. Good. Yes. Look at what she just said. She said it goes up by the odd numbers. Hashara, like legit, I've been doing this for years. I don't think anyone has said that answer that I wanted them to say on the first try ever. So thank you.
Oh, you're welcome.
Yeah, no, that was good. So think about what she just said. That's exactly it. That was kind of a sophisticated answer for a second grade Hashara, right? So up by 1, up by 3, 5, 7, 9, 11, 13, yada, yada, yada. So if you had to now figure out the next number in the pattern, how much would you have to add to 49? So anybody want to tell me what you would add to 49 to get that next number? Go ahead, Paige.
You would add 15
Right.
because like you notice that each of the odd numbers increase by 2.
Right. That's another thing. People are always like, oh, to get the next odd number, they think you have to add an odd number because they're like, oh, if you started at 2 to get the next even number, you add 2. So 2 plus 2, 4, 6, 8. And when people aren't thinking, they're like, oh, so when you want the next odd number, you add like 1 or 3, but you actually add 2 because it's every other number, right? So she's right. You'd add 15 to get the next one. So if we added 15 to 49, anytime I add 15, I always add 10 and then I add 5. So 10 more would be 59 and then 5 on top of that, 64. However, what about modern day you, present day you, high school you? When you see this list of numbers, what do you know about this list of numbers? Who is this? Who are these people? What family of numbers are they? Or what can you tell me about 0, 1, 4, 9, 16, 25, 36, 49, that elementary school you maybe didn't know about those numbers? Who wants to share? I have, oh, go ahead, Justin. What do you know about those numbers?
I know all of them besides 0 and 1 are perfect squares.
Well, 0 and 1 are perfect squares. Because what's 0 times 0?
Oh, yeah.
Right? And what's 1 times 1?
Yeah, 1. So they're all perfect squares.
Yes, exactly. So they're all perfect squares. And now I want you guys to even think about what Justin said because you guys do this a lot. Whenever 0 or 1 come up, because they're so plain, very vanilla numbers, you know, they're very plain. Everyone kind of thinks they're not like the rest. So it's like you could really wrap your head around 2 times 2 is 4 and 3 times 3 is 9. But these are like, meh, those weird things. But don't forget, they work the same way. They're still perfect squares. All right, this is all good. Okay, you're all with me. So another thing that I'm going to connect all these dots literally and figuratively. Remember I said that, my little joke. So when you were also in middle school side, you used to graph. Do you remember graphing in middle school with making a table of values? Does that sound a nod, a thumbs up, a hand raise button, anything? Like you would make a table and then you would connect the dots like ordered pairs. So you'd have all these X's and then fill them into an equation for X and get the Y. Yeah. Okay. Now, if I were to make a table of values, it usually works in that way where you fill in X, okay? You fill in the X because X is what we call an input. You literally put it in the equation, and then Y, the way we structure our equations, is our output. It's what we get out of it. So it's like you have a quarter and you put it in the little, at the supermarket, you know, the little gumball machine looking things, right? Quarter is your input. You put a quarter in, all right? Turn a little knob, you get a toy out, okay? That's your output. So here's where the Y's go, but you need to define what Y is. So I'm going to define Y. Y will equal X to the second power, or X squared. Now nobody, I'm lazy, we're all lazy. Nobody wants to make a table of values every time they graph. Like, come on, that's annoying. So what I'm going to show you today, you'll never have to do this again. Okay, you're going to do it one time. Well, for parabola, you'll never have to do it again. So X squared. Now, a popular set of numbers that they would give you in elementary school, they would tell you to do -2, -1, 0, 1, and 2. Oop, right there. Okay, so those would be the numbers we would fill in for X. And then we would get certain answers out for Y. So let's do a little work on the side. Y equals, anytime you plug in, people like to bust out their calculator. And I think Paige, you asked me, was it Paige? With the negative number. And you were like, oh, but I plugged in the negative squared and did this and that, and I got this as my answer, and that's not what you got. And we talked about, yeah, right? And we talked about how, like, if you don't put those parentheses, it really messes up your order of operations. So I'm going to make this 5 times. Y equals parentheses squared, y equals, got 3 of them. Oh boy. I'm not going to fit them all, am I? I'm going to really push my luck here because I don't want to go to the next line. Eee. Okay. So let me, there we go. Okay. A little squished, but we'll do our best. So I have all these, and I'm going to fill in -2, -1, 0, 1, and 2. -2, -1, 0, 1, and 2. So here's my master equation. This is actually, when it's plain like this, and we'll talk more about this, it's called a parent function. And then when we start moving, remember vertex form, to the left or right, or if we move something up or down, or if we play with that negative, which impacts your end behavior. If it was positive and even, it was up, up. If it was negative and even, it was down, down, and so on. Those are all transformations of the parent function. So the parent is like the plain basic one. So you ever made like a paper doll in elementary school for something, right? And then you put the little clothes on it, you color it, you put your hair on it, whatever. So y equals, what do I get when I do -2 squared? I get y equals what number? Just shout out at me so I could write them down.
4.
4, good. What about y equals, and if I have -1 squared, I get y equals
1.
1. 0 squared,
0.
good. 1 squared,
1.
1. That's an easy one. Come on, guys, don't be shy. And 2 squared,
4.
4. Perfect. Okay. Then these actually make, so I'm going to write these numbers down over here, -2, 4, -1, 1, 0, 0, 1, 1, 2, 2. This all represents, I'm going to put parentheses and a comma, ordered pairs, x, comma, y.
You put 2 instead of 4 for the last one.
Oh,
Yeah.
thanks. There we go. I like it when you could kind of fix it without having to do too much, you know. You kind of get some, I've seen, because I tutored for a long time, some really creative ways that kids like have changed numbers into another number when they write in pen and they don't want to erase. They're like, man, and they're like, some, it's like an art form. And I'm like, wow, I would never even be able to tell you had the wrong number written there. Okay, so those are my ordered pairs. Now, obviously, I could keep going and I could plug in 3 and -3, 4 and -4, 5 and -5, but we should kind of understand that if I plug in a positive number or a negative number, I'll get the same output for either one, because when you square something, it becomes positive, unless you have a negative out in front of that parenthesis. Okay, now, over here, I have my graph paper, and always think about your points before you draw your graph, because you don't want to draw a part of your graph that you don't need, right? So I'm actually going to go vertical on this, and I'm just going to quickly go in. I'm going to draw my y-axis. You don't have to copy all this right now, but the trick is the game changer right now. Okay, I have my x and y axes. Your x is horizontal, and your y goes up high. Okay, y goes up high. So there's your y-axis. And my origin is where my vertex is. If you think of this as vertex form, if I rewrite that parent function in vertex form is the one we wrote, y equals a parentheses x minus h squared plus k. I'm giving you guys gold right now, so I hope we're all paying attention. Well, here, if I rewrote this to look like this, well, a is just 1, so I guess I could write it. There's only x being squared, so I could write -0 squared, kind of like placeholders when we did long and synthetic division. And I don't have anything add or subtract at the end, so I could put +0 at the end. So your vertex is to the left or right 0, and then up or down 0. Okay, just gonna grab feel like you can't even really tell when I use color pen on this, but we'll try. So my vertex is going to be at my origin, right over there. Actually, what the heck? This is a brand new pen. It's not really working. All right, and then if you were, like I said, a little kiddo, little baby you, and middle school, and you learned make a table of values to graph, sorry, these pens are stinking it up right now. You would connect all the dots and make your graph. So there's my 0, 0, over 1, up 1, back to the origin, I have 2, comma 4, so that's 2, comma 4. Then I had -1, up 1, -2, up 4, and you have more dots. The more dots or points you have, the better your graph's going to be, like connecting the dots. That's why I said literally and figuratively before. The better it's going to be. So if I plugged in 3, so again, that was 1, that was 2. If I plugged in 3, or if I plug in -3, what y value am I going to get? If I plug in 3 or -3, what y value? Go ahead, Ella.
6.
Careful, squared, not times 2, I think.
Oh, 9.
9, good. So we're already up here. This is 4, where I left off, right? So think about what I'm going to do. I need to go to 9. Instead of going over here to 3 and then counting 9 boxes up, because the numbers are going to get big fast. I know right here, I'm already up 4. So all I'm going to do is I'm going to go over 1 more unit. Now I'm at 3. And if I'm already at 4 and I need to go to 9, how many more boxes up do I need to go to get from 4 to 9? How many more boxes up do I need to go? Anybody?
5.
Yeah. So I'm going to go up 1, 2, 3, 4, 5. It's just a cheap way to get my other point, right? Same here. I'm over 1 more. Now I'm at -3. 1, 2, 3, 4, and 5. What if I wanted another point at 4? If I go here and plug in 4 for x, what do you get for y? If you plug in 4 for x, what do you get for the y, your output? What's 4 squared?
16.
16. Now, again, do I really want to go over 4 and -4 and then count all the way 16? No. Make your life easy, right? I'm already up 9. If I go over 1 more, now I'm at 4 and -4. How much further do we need to go to get from 9? I'm already up 9. If I want to go up in total 16, how many more boxes?
7.
7. So all I'm going to do from here is count up 7. 1, 2, 3, 4, 5, 6, 7. So instead of having to count 1, 2, 3, 4, 5, 6, 7. So instead of counting up 16, which you're going to get tired after a few boxes, you're going to be like, well, whatever, and you're just going to draw it and call it a day. Now I have a lot of points on here. When you have a lot of points on here and you try to draw your parabola, it is way easier. Even if you straight up used a ruler and connected the dots with straight lines, most people wouldn't even be able to tell. So let me show you what I mean. So say you're like mine's a little lumpy there. So you're like, I'm a really bad artist and I can't draw. So you bust out your ruler. If you connected even these with like a ruler, oops, not that dot. Oh my gosh, what am I doing? Wrong dot. I'll wipe that out in a minute. But if you just went along and connected them with a, I should hold this down a little bit more. Steady. Okay. Even if, see, I use the ruler on these. These are straight lines, so it's actually like sharp right there, but like who can tell? No one. It looks better than the one I tried to draw curved because it looks like a little dimple right there, you know? So what this does is it gives you a lot of dots. So when you connect them, you know, your graph is going to look a lot better. Okay. So let's see how ugly that one was. Yeah. So this was up 4. So I'm going to go over 1, up 1, 2, 3, 4, 5 is where I was supposed to go. And then if I use a ruler, I'm going to connect that dot and that dot like I did on the other side. And then that dot to that dot right there. It looks even better than when I tried my best to draw it curved. It looks kind of bad. Like I said, it kind of dimples a little bit, and that's not cute. Well, there we go. I'm making a mess, but you guys get the gist. whatever. Okay, so how can we use this to be helpful? And I hope you guys already all uploaded your homework examples. I think it was like 4 questions, right? That I wanted you to go over graphing. So I hope you already uploaded it. And what I'm going to do with homework is, and I'm just going to remove this. I'm going to really get into that shortcut right now. Is I'm going to check on the day that it was due if you submitted it on time. If you turned in decent looking homework, even if it's not perfect, on time, I'll give you 2 out of 2. If it's late, 1 out of 2. And if it's not there, 0 out of 2. Then 1 week after it's due. So if it's due today, so 1 week from today, I'm going to go back to that assignment and then I'll grade it for accuracy. So what does that mean? That means you had a whole week to go and fix your homework. If I go over it in class, fix it. If you didn't even do it, at least copy it when I do it in class and upload it to at least get credit for having it done and done correctly. If it's got mistakes on it, don't delete the pictures of your mistakes, leave it. Okay? Add pictures of the corrections. So can somebody give me one of the equations that I gave you guys for homework, one of the ones in vertex form? Let's start there. Can someone read me one of the examples from vertex form? I'm going to show you how this trick will make your life easier. Give me the one that has like, doesn't have the number in front of the parenthesis.
Okay. Y equals x plus 1 to the second minus 3.
Okay. So when you don't have a number in front of your parenthesis, okay, no number in front of it, right? That means it's got that basic pattern that Hashara taught us before. It's going up by the odds. So remember this. What number is in front of this parenthesis? Really? An invisible 1. So if it's an invisible 1 or if it's a negative 1, negative. The pattern of that parabola is the Hashara pattern. Okay, Hashara, we're gonna name it after you. It's the Hashara. It sounds beautiful. Okay, that sounds like it could be like a real name. So like when you're in college math class and you're like, oh, I have to do the Hashara. And people are like, I never learned the Hashara. You could teach them the Hashara. So the vertex, based on vertex form, what is the vertex for this guy right over here? What is the vertex? Plus 1 on the inside means one thing, and then minus 3 on the side means another thing. So, Liana, what's my vertex going to be for this cutie patootie over here?
-1, -3.
Good. It's the opposite of what's in the parenthesis, and then it's the same as what's next to it. So, right there. There's my vertex. Then we could find, I asked you for the y-intercept, the axis of symmetry, the mirror point, end behavior, and then graphing, right? So what was the second thing I asked you for, and what did you get for that one? You want to say, Ella, what was the second thing I asked you guys for?
The y-intercept.
Okay, and what is the y-intercept? This is where some people struggle on the y-intercept. What's the y-intercept for this one?
So the x is 0, and then you plug in the x in the original problem as 0 and solve for it.
Good, and then what'd you get for it?
-2.
Okay, good, nice. A lot of people always want to put like whatever that number is as the y-intercept, but that's only if it's in standard form, so you don't want to mix that up. All right, y-intercept, vertex. What did I ask you guys for next? What did I ask you guys for next? I asked you to find, what other thing? Go ahead, Paige.
The mirror point, I got -2, -2.
-2, -2. Sounds good. The x is double the x of the vertex, and the y is the same as the y-intercept. Okay? Then I asked you for the axis of symmetry, and that's always going to start off as x equals a number. And what is my axis of symmetry number going to be? What is my axis? How about, go ahead, Adriana. I couldn't hear because I think the volume was a little low for your mic. -1, yes, got it. X equals -1. It's always going to be the same as the x of the vertex. All right, what about end behavior? I know we did end behavior a while back when we first graphed polynomials in general. And we used our mnemonic device for polynomials was stinky Yetis enjoy ballet and fuzzy zombies play mind games. We're going to talk about that again. But if you think back to that, you might flip back to your notes. You have positive leading coefficient and your power, if everything was expanded, your biggest power or degree is 2, which is even. Positive and even. What's the end behavior for that? Go ahead, Isa.
It's up.
Up and up. It's up on the left and it's up on the right. Good. Okay. Now you had to graph this, and that's maybe you're like, I found all that. Once I have to put on the graph, bleh, I hate it. Well, let's do the trick. It's up and up. That means that your vertex is going to be like the bottom, like this. So I need to just, this is a double trick. I'm teaching you 2 tricks at once. So I'm teaching you the Hashara, and then I'm also going to teach you the little axis hack, where you ever draw on your paper your X and Y axes, and then you realize like you don't have enough room to plot your vertex, and you wasted all this space, like you made all this room with these quadrants, but your whole graph is like only over here in the corner, and you're like, well, that was silly, like my graph looks ridiculous now. So this hack will make it so that never has to happen. So what I do now is I just put my vertex right in the middle of the space. So I'm going to put my vertex, bam, right there. Okay, done. Then I look and I see that it's a 1 or even a -1 out front. My end behavior is up, up. So I know I got to do this. I know it's got to go whoop, like that. I'm going to do the Hashara from my vertex. I don't care where the vertex is. If it's at the origin, if it's at your grandma's house. From your vertex, ready? Listening with your brains and your eyes. You're going to go out 1 unit, up 1 unit. Then you're going to go out 1 unit, the Hashara, up 3 units, the Hashara. You're going to go out 1 unit, up 5. I have a little room here. Let's go wild. Out 1 unit, up 7. I'm really pushing my luck here, huh? There we go. Okay. I have all my dots on my paper. Beautiful. Amazing. Now, maybe you can't draw a curve. You bust out your ruler. You just go along. You connect. You should go this way and this way. I just hold the pen down, tilt my ruler, hold the pen down, tilt my ruler, extend it, stick an arrow at the end. Now on this side, hold my pen down, tilt my ruler, hold the pen, tilt the ruler. It honestly doesn't really look like I used a straight ruler to draw it. Maybe a smidge over here. Now, I drew my parabola, but now my axis hack. That's my vertex, which is apparently left 1, down 3. So if this is, think carefully. People do this backwards all the time. If this is supposedly left 1 unit, it's left from the y-axis. I know it's an x value, but it's left from the y-axis. So here's my y-axis. My vertex is to the left 1 unit. So I don't know, what's left for you guys on your screen? Is it this? Did I move left with my pen?
Yeah, that's right.
Okay, because I might be flipped on my screen, you know? So left 1 unit. So if that's left 1 unit, then where do I draw my y-axis? Right 1 unit. So if this is left 1, my y-axis should be right 1. So now, after I have my picture already drawn and beautiful, I go over here, and now I draw my y-axis after. Here's my y-axis. Beautiful. Okay, now this is apparently down 3 units. Down 3 units. So I'm going to draw my x-axis where? From my vertex. Where do I need to go to draw my x-axis? You could shout it out at me.
3 lines above of
Yes. So I'm going to go up 3 lines above it. 1, 2, 3. And guess what that is? My x-axis. So what is my axis hack do for you? You just draw your graph where you want it and you make the axes after, because then you don't have to worry where you accidentally drew like too much space here or too much space there. You don't have to waste all the space in your notebook. Okay, so now check it out. Here's the origin. Left 1, down 3. 1, 2, 3. There it is. What about your y-intercept? It's supposed to be 0, -2. Origin over 0, down 2. There it is. What about my axis of symmetry at x equals -1? There it is, right in the middle, of course. What about my mirror point? -2, down 2. There it is. So normally you would only have these 3 little babies, but look at all these points I have because I did the Hashara, and I have this amazing parabola every time. So this is a great trick to draw the most amazing parabolas ever. But what about when there's a number out front? Okay, so I'm going to show you that right now. I'll make that a separate video. So I'm going to end this recording. So in this recording, what do I want you to get out of it? 2 things. If you know where the vertex is, or can figure out where the vertex is of a parabola, parabolas are a very special group of graphs. If you know where the vertex is, and if it's a plain Jane 1 out front or -1 out front, okay? The pattern of a parabola, Hashara, okay? Think Hashara, she gave us that pattern. All my perfect squares, that's how we make a parabola, is with x squared. All your squares, how do we get from one to the next? You keep adding the odds. So how can you draw a beautiful parabola? Use the Hashara, the odds. Once you have the vertex, out 1, up 1. Do it again. Out 1, up. What's the next odd number? 3. Out 1, up. 5. Out 1, up. 7. And go on and on and on. That's if it's regular plain out front. Okay? That's one thing I want you to get from this. And the other thing was my axis hack. And what's the axis hack is you draw your graph first. Where do you draw it? Right in the middle of the space you have. Think about your end behavior. It's opening up. So it's like up, up, and your vertex will be when it's opening up, up, that means you have a minimum point. You have a low point. If it were opening and it was down, down end behavior, then you would have a maximum. So you just think about that before you start putting it on the paper. You draw your parabola right where you want it, and then you carefully just go backwards to figure out, well, if this is apparently left 1, then I need an axis to the right 1. If this is apparently down 3, then I need an axis up 3. So you go right 1, up 3 to draw your axes. And bam, amazing. So what about when there's a number out front? So, I'm ending this video. I'll tag, or what do you call it? I'll put the little card on the screen at the end of this video where you can click to the next video, which will be, what do you do when it's not a 1 out front, like a 2? I think I gave you guys an example with the -2 out front vertex form. Is that correct? So we're gonna do that in the next one, okay? So if you understand this and you like the trick, you'll put a thumbs up. If you're like, what the heck is this crazy lady talking about? Help, SOS, put thumbs down, okay?